Okay, we're going to solve a system of three variables, and these are linear equations. Notice there's an x, y, and z, and in this top one, you would just go ahead and tack on a 0z if a z does not exist. So when you're solving a system of three variables, the first thing you do is pick two equations of the three that make it the easiest to eliminate one variable. So the first thing, whoops, darn it, sorry about that. First thing I did is I noticed that this equation and this equation each have a y that can be eliminated. Notice that they each have a z, but because this has a 0z, we're not going to eliminate z's. We're going to eliminate the y's. So I went ahead and rewrote these two equations over here. And because the positive 3y and the negative 3y are opposites, we're just going to use the addition method of solving equations. So negative 3x plus negative 1x and negative 3x equal negative 4x. Those cancel. These happen to cancel. And then negative 15 and negative 5 add up to negative 20. And then, since those things zero out, we can eliminate that. And then we're going to divide both sides by negative 4. And we get x is equal to 5. Negative 20 divide negative 4, x is equal to 5. So that is steps 1 and 2. Steps 3 and 4 is pick two more of the equations and eliminate again. So I'm now going to pick this top equation, and I chose this bottom equation because the positive 3y and the negative 3y are opposites. We can use the add method. And then I went ahead and performed the operations. So I'm going to add all the columns. So the x's add up to negative 7x. Those cancel. The z's add up to negative 5z. And they're equal. The constants add up to negative 25. Okay. And technically, I'm going to show you kind of something cool. Well, let's do the final steps first. So this first equation that we got, before I crossed out the 0z, so this first one, we're going to add together this one right here. Now, you would have to proceed because the x variables don't zero out and the z variables don't zero out. So I want these to zero out. So I'm going to multiply this top row by positive 7 and the bottom row by negative 4. That way the x's will cancel. So negative 4x times 7 is negative 20x. 0z times 7 is 0z. Negative 20 times 7 is negative 140. Now I'm going to do the bottom row. Negative 4 times negative 7x is positive 28x. Negative 4 times negative 5z is positive 20z. And negative 4 times negative 25 is 100. And now that these are opposites, we can add the columns. Those cancel. 0z plus 20z is 20z. Negative 140 plus 100 is negative 40. Divide both sides by 20, and you get z is equal to negative 2. And now that we have two of the variables, I'm going to come over here. So we've done all this stuff. Now that we have two of the variables, so of our x, y, and z, we have our x, we have our y. We can just take one of the equations here and substitute in the x and the z, or in this case, we could just substitute in the x and solve for y. And that's what I did. I like to keep things easy on myself. So I just substituted 5 into that top equation. So I have negative 4 times 5 for the x plus 3y. There is no z, so I don't even have to worry about that negative 2, is equal to negative 20. Notice this and this are the same, except for I substituted 5 for the x. And then negative 4 times 5 is negative 20. And that side's, they're the same. They're going to cancel. And if you recognize that they're going to cancel, you can just cancel. But if not, add 20 to both sides. And then you get 3y is equal to 0. When you divide both sides by 3, y is equal to 0. And so now we have our solution set for that entire system. Okay, that's it for this one.